Hey guys, it's Mr. Doiron. Welcome to the very first math video that we're going to have this year. We're starting a new unit. This unit's called Similarity and Transformations. We're going to start with the similarity part of it, talking about things that are similar, so that means very alike to each other. So the first topic we're going to talk about is scale diagrams. So here's just an introduction to what scale diagrams are. So what are they? A scale diagram is a drawing of an object that's the correct shape, but it's either enlarged or reduced, so bigger or smaller. So it doesn't have to be a drawing, it could be a model, but often they're seen as drawings. So here's an example comparing the heights of some famous landmarks around the world, drawn to scale, so seeing that the CN Tower is more than twice as tall as the Calgary Tower. Why might someone need to create a scale drawing? Well, when the object they're trying to draw is too large or too small to fit on the piece of paper that they're drawing on, they would use a scale drawing. Right? So, for example here, if you wanted to draw some diagrams of a whale, you'd have to use a scale because you couldn't draw a full-size whale on a normal piece of paper. Same with an insect. You want to see more detail, you would draw a diagram of an insect made bigger so you could see it. What are some more examples of scale diagrams? For example, any map that you look at is a scale diagram. The land would be the correct shape, but the map is clearly much smaller than the area that it's showing you. So here's a map of Manitoba. You can see the lakes and rivers are in the right spot. They're all the right shape, but this is a lot smaller than the actual Manitoba. Another example would be an IKEA instruction manual. The diagram is the same shape as the object that you're building, but the drawing is smaller than the actual object. So here would be, I think it's a fake one, but a diagram of a house. It's the same shape as the actual house that he's building, but it's a lot smaller than the actual house. Yet another example would be a drawing of a human cell. It's impossible to draw a cell to be the size of an actual cell, so you must make the drawing bigger so that you can see stuff about it inside. An important term that you may have heard that we're going to be using when we're talking about scale diagrams is the word corresponding. Corresponding means similar in position or associated with. So having a very close relationship with, basically. In scale diagrams, a part of the drawing is said to be corresponding to the same part on the actual object. So again, here's a map of from Steinbach to St. Anne. So this shows Highway 12 from Steinbach to St. Anne. The Highway 12 on this map is corresponding to the actual Highway 12. It's just much smaller and easier for us to see all in one piece. So what are some jobs that involve scale diagrams? Real world application. Well, there are actually many jobs that require people to design products using models or diagrams. So for example, architecture. An architect would have to deal with floor plans for houses. They would create blueprints, etc. for people to build houses. Someone else that works in the housing market would be an interior designer. They would deal with diagrams of houses, rooms, etc. So for example, here's something from the Bureau of Labor Statistics from the United States. So it's not Canadian, but it would be quite similar. You do need a degree from a college or university to become an interior designer in the States. But they not even start paying. This is the middle pay. Middle pay is around $50,000 per year or $23 per year, so per hour. So once you get going, you could actually make quite a good living being an interior designer. What else? There's auto designers. They would have to make scale diagrams and models of vehicles. So here's an example of a guy. His name is Chip Foose, and he creates models for cars, whether it be drawings or otherwise. So you can see here he's created a couple of drawings. Here's some more, some stuff he's working on. A 2006 Stallion, for example, you can see how detailed his drawings of his wheels are. You can actually purchase these. This one's sold out, but some drawings here. Also, he has couple model cars here. This is the same idea, right? It's the same shape as the actual car, just scaled down quite a bit. You can buy it for $6. One more occupation would be anything in tourism, because you'd be dealing with maps an awful lot. So you'd have to know how to read the maps in order to tell people where to go and how far to go. So blueprints, diagrams of cars, or maps are all things that you might have to use in an actual job when it comes to scale diagrams. So here's a question. Can you think of 2 other jobs that involve scale diagrams? Pause the video now and think of those and jot them down. Could you think of any? Hopefully. We'll talk about this in class once we all get back together. So here's something pretty cool that I found on Google Maps. I'm sure you've all used Google Maps before, but here's something that I noticed. Here's St. Anne Collegiate, that's where we are, where we go to school. Notice down here in the bottom right corner, there's a certain length here, and if you measured this length, every time you go this distance on the map, you've gone 100 meters. Watch what happens when I zoom out a little bit. Now this distance, which is very similar, is 200 meters. So keep watching down here. As I zoom out, now it's 500 meters, a little bit longer, but same idea. You measure this distance, you've gone 500 meters. Now it's 1 kilometer. So if I keep zooming out, if I can see most of Manitoba here, or a good chunk of it, now each time you go this distance, it's 100 kilometers. So if you zoom way out, now it's 1,000 kilometers, which is the farthest out that Google Maps goes. So notice every time I scroll, that distance changes. I thought that was pretty cool. What we're going to be doing in class today, we'll be working with maps a bit. So we'll have a couple of atlases. We'll be measuring some distances using a scale. So you'll have a ruler like this, and there's a scale on every map, so you need to measure that. Say, okay, start at 0 with my 0, bring it up close, and you can see here, every centimeter, 1 centimeter is 300 kilometers, 2 centimeters is 600. So every 1 centimeter I go, I've traveled 300 kilometers. So for example, if I wanted to measure from, let's say, Edmonton over here to Winnipeg over here, you take your ruler, you'd spin it to the right angle, and you'd measure. So from Edmonton to Winnipeg, it's about, let's say, 3.8 kilometers, or centimeters in this case. So on the map we've gone 3.8 centimeters, and each centimeter is 300 kilometers. So times 300 equals, let's find out. So we have 3.8, so 3.8 times 300, we get 1,140 kilometers in real life. So this is what we're going to be doing. Make sure you know how to do this. If you have a map at home, you can try it on your own. But yeah, be ready for this in class tomorrow. And yeah, have yourselves a great evening. Thanks.